and he developed banana micronutrient mixture, very popular, that is called Banana Shakti. And he also developed fertilizer tailoring equations for banana varieties like Nandran, Povan, Karpuravalli, Nepovan, Rastali, and Grand Naini. And he also developed package of practices for integrated nutrient management in banana cultivation. And SAR also developed strategies of using human urine as a fertilizer source in banana cultivation. So in his career, SAR published 72 national research papers and 11 international research papers, and participated in 137 different conferences, symposiums as a national and 7 international. And SAR published 4 books and 8 book chapters. And he has given 30 radio talks, TV talks, and written 92 popular articles in his career. And he also guided 6 MSc students and 2 PhD students. At current, SAR working on DBT project, that is nano micronutrient mixture of banana. So with this brief introduction, I welcome you, sir. And I would like to give opportunities to sir to take class and continue the class. Sir, please. Hello. Sir. Sir, am I audible? Hello. Sir, please unmute your. Hello. Hello, sir. Hello.
Hello.
Sir, am I audible? Sir,
yeah,
am I audible?
Some technical problem is there. Okay,
please. Sir. Sir, please continue, sir. Please.
Introduction is over.
Introduction is over, sir. Please continue.
I will share my screen now.
Okay, sir.
Hello.
Sir.
Is it visible?
Yes, sir. Visible, sir. Okay, sir. Yes, sir.
Sorry for the disturbance. Actually, some technical hiccups is there here.
Okay.
So, welcome, friends. Good evening. Today is my topic is the nutritional management and the physiological disorders in banana, with special emphasis on micronutrient imbalance. So, as introduced by our friend, I'm Dr. Jayabaskaran. Basically, I'm a principal scientist soil science here, working here for since 27 years. I have experience of doing some fertilizer management researches and this fertility adjustment equations also we have developed. And these are my experience background. And just I will move on to the next slide actually, because before knowing that nutrient management, so whether the soil is suitable for banana cultivation or not, that should be known actually, because some of the factors in the soil may be of limiting factors which affect the nutrient mobility, nutrient uptake, or nutrient assimilation also. So first of all, we have to see whether our soil is suitable for banana cultivation or not. So in that case, we have to, in this slide, I am just explaining this soil suitability classification. This middle column, it is then up to this range. We have categorized the soil into best, good, moderate, bad, worst soil. So based on the 3 categories like climatic condition, land as a whole, or soil type, we have categorized into 3. And in that, so many gradations we have made. And up to, for example, the climatic condition for banana cultivation, the rainfall should be at least 800 to 900 mm should be there. So without which we cannot do banana cultivation there. Beyond that, if it is less than 700 or less than 500, we cannot do banana cultivation. If the underground water resource is very high, then we can do with some manageable level. Then the mean annual mean temperature should be between 25 to 35. And as a land as a slopey soil, if you take up to 5% slope is permissible for banana cultivation. Beyond that, land is not suitable for banana cultivation. Then erosion classification we have taken as a moderate type, and for drainage also moderately drained. It is up to that moderately drained category. It is okay. Beyond that, poorly drained soil, it is very difficult for banana cultivation. In case of banana, if you see for 2 days, water is not there. The scorching effect will be there in banana cultivation. At the same time, if 2 days inundation of water is there in the field, the wilting effect will be there. So it is a crucial category, crucial aspect we have to consider, like drainage properties of the soil. Then surface storiness up to 5 to 30% it is allowed. Beyond that, that is not suitable for banana cultivation. Like that, soil chemical properties, then physical properties. If you see that loamy type soil is suitable for banana cultivation, up to clay type also it is okay. It should not be of expandable type. Then soil depth also, you can see this type of categories. Then pH, EC, chemical parameters also. So up to this level, the banana cultivation is suitable for this condition for in the soil categories. Then next slide I will show. So let us see what is soil. It's a simple abbreviated term of soul of infinite life, because all the living materials are generating from the soil, and after its death, it is going to the soil only. So that's what all the living material, it is generated from the soil. It is called soul of infinite life. That's why it is called soil, SOIL, soul of infinite life. If you ask a farmer what is the input we are using for agriculture, he can say seed, water, fertilizer, water maybe, but he forget to tell that the soil is also input for the banana cultivation or any cultivation of a crop. So soil is very important thing. Just we have to see whether the soil is a fertile condition, then only the nutrient management aspect will come. So soil is very important. You might have seen this type of classification for soil, like as a mode of formation, as mode of color of the soil, and the type of the texture of the soil also. We can classify in different categories like alluvial soil, then sandy soil, clay soil, black soil, red soil, calcareous soil. So many types of soil. You may be knowing that the soil is made up of 3 categories of particles like sand, silt, clay. That fractions, the proportions also is playing major role in considering that whether the soil is suitable for banana cultivation or not. So we have to see the proportions also. You might have seen this type of USDA classification of soil textural properties. In that case, you might have seen this type of triangle also. One portion it is indicating that clay portion, and there's in this axis indicate the silt portion, this axis indicate the sand portion. The proportion should be of different categories, but I have given this slide. In this slide, you can see this red bordered region. So this classification in this region, this type of textural soil only it is suitable for banana cultivation. Beyond that, it is not suitable for banana cultivation because of the misproportion of the soil particles. So based on our experience, based on the research, we categorize the soil like a clay type, some of the portion of the clay portion, silty clay, silty loam. This region only is suitable for banana cultivation, not beyond this. So this is another type of category. And then you might have seen this type of calcareous soil, and sometimes this black cotton soil also, where wetting and drying may create this type of large cracks in that. So this is also a very problematic one where banana cultivation is weak. So we have to see whether what type of soil is there existing in the land itself. So before going for the nutrient management aspect, because these are all the limiting factors. Beyond, it is not in our hand. So we have to select the soil properly. Otherwise, total banana cultivation will be of a loss. So this type of problem will be there. In case of a black cotton soil, you might have seen this type of deep cracks up to even 3 meters deep also will be there. So like this, if once the drying is there, deep cracks will be formed in that case. So what happens immediately after letting water, all the soil particles existing on the soil surface will be falling inside it. And after that, due to expansion type of clay, it is closed. What happens? The topmost soil is entering into it and it is going down, and the lower soil is coming up. So it is called self-churning soil, inverting soil. You might have heard about inverted soil. Wetty soil, that is in the black cotton soil, it is happening. What happens? It is self-churning soil. If a banana, if you imagine that some banana crop is there, it is standing there, soil is moving and here and there, what happens? The corm will not be remaining stable condition. So in that case, what happens? The root will be damaged and you will not get the proper plant growth. So how to select the proper soil, suitable soil for banana cultivation? Say for with available material with us in our home itself, house itself, we can do some test whether the soil is suitable for banana cultivation using some old glass bottle or somewhere you can take. You can fill it up to the maximum to the water, and you can drop some handful of water where you want to do banana cultivation. From there, you can collect the soil and drop it inside it, and stir it for 5 minutes and keep it aside for half an hour. After half an hour, if the settlement of the soil is like this, it is happening, it is okay for banana cultivation. Even after half an hour, the suspension is remaining as such. There is no settlement at all. If you put a stick inside it and it is opaque and it is not transparent, it is not visible, means this type of soil is not suitable for banana cultivation. That means it is having some suspended particles because of the presence of sodium. Sodium is the major limiting factor that affects the nutrient uptake, nutrient assimilation, everything is there. So this type of soil should not be selected. Even after that, if you pour some turmeric powder, if you add to this, if you get some reddish tints because of a high pH, that is called saline sodic soil also will be there. So this type of soil should be avoided for banana cultivation. Then this is the soil type. If unknowingly or unfortunately you have selected this type of soil, means you might have faced this type of problem. This is the marginal chlorosis. It starts from the lowermost leaf because of the sodic property of the soil. Due to the presence of a high amount of sodium, what happens? The sodium is accumulating in the lowermost leaf from the margin region. So it is giving a scorching appearance, and totally the total leaf surface will be damaged, and the yield reduction will be up to 20 to 25% because of this problem. So unknowingly, if you are selecting this type of a soil, the nutrient management will not help in banana cultivation, even if you do proper nutrient management. This is the limiting factor. So we have to do elimination process before starting banana cultivation, which is good, which is not good. We have to know. Based on that only, we have to take our decision whether the soil is suitable for banana cultivation or not. Accordingly, we can take. Then let us see, you might have gone through this essential elements for any crop. Essential elements, the nutrients which are very essential, which cannot replace other element with another one. And this is the essentiality of the nutrients. There may be some classification also, like macronutrient, micronutrient. Even the macronutrient also subdivided into primary macronutrient and secondary macronutrient like this. Say for example, for 1 hectare of banana production for optimum yield, at least for nitrogen, some 400 kg of nitrogen is required for optimum banana production in 1 hectare of a crop. In case of a phosphorus, it is nearly some 50 kg of phosphorus it is required. So these are all the nutrient requirement I'm just talking, I'm debating here. And you can wonder, see, 1500 kg of potassium is required. So banana is a heavy feeder of potassium. This much of potassium is required to get a good quality yield. Otherwise, we cannot get yield of the banana properly. So this much of potassium is required. These are all the primary macronutrients. Then the secondary macronutrient like calcium, nearly some 250 kg of calcium is required for 1 hectare of banana. In case of magnesium, it is 125 kg of magnesium it is required. In case of sulfur, it is nearly 75 kg of sulfur it is required. So these are all macronutrients, primary nutrient, micronutrient, macro secondary nutrient, and this much is required for banana production for 1 hectare optimum yield. So in case of micronutrient, let us see. In case of manganese, it is nearly 12 kg of manganese it is required. And in case of iron, it is 6 kg. In case of zinc, nearly some about 5 kg of zinc it is required. And in case of boron, it is 1.5 kg of boron it is required, and nearly 0.5 kg of copper is required. It is the least one. So micronutrients also very essential. We can say it is only micronutrient, but micronutrient is very essential. The presence of all these micronutrients in this proportion only will be helpful for uptaking of this type of macronutrient properly. Otherwise, in the absence of all this micronutrient, definitely the macronutrient use efficiency will be destroyed, deteriorated, and it will create so many problems. So we have to see the balanced nutrition aspect here. Otherwise, we cannot survive in banana cultivation. So let us see one by one how the deficiency symptoms appears. In case of nitrogen, that is macronutrient, that is primary nutrient, macronutrient. This one, the nitrogen deficiency. You can see this pseudostem region, pink coloration is there. At the same time, the leaf, you see the leaf lamina, you see that pale yellow or light green coloration is there because of the non-formation of chlorophyll. Chlorophyll lacking is there due to nitrogen deficiency. You can think that it is a red banana, but it's not red banana. It is due to nitrogen deficiency. It is a variety Puvan. It is called Puvan. But here we have this type of pink coloration. Even the petiolate region, you see, this also pink coloration is there. This is due to nitrogen deficiency. I will later I will tell how to rectify it. First of all, let us see one by one how the deficient symptoms are appearing. Then in case of iron nitrogen deficiency, you see the leaf orientation. It is not of a twisted type of leaf orientation. In a single planar leaf orientation is there. It is like a traveler's foot palm symptoms. It is called like some ornamental plants also you might have seen this type of orientation. But in case of a real banana, this traveler's foot palm appearance is there because of the nitrogen deficiency. This is a malformed leaf orientation. Then in case of nitrogen deficiency, you see, in our experimental plot, we have done some gradations also. Here, at 0 level of nitrogen, the plant growth is stunted and leaf pale coloration is there. Here, 100% nitrogen applied field, adjacent field, you see that the growth and the gigantic look when compared to this type of suffering one. So that coloration also is a dark tinges. So nitrogen creating lot of variations, and the chlorophyll synthesis also it is depending on nitrogen content also. So in case of a nitrogen deficiency, it may be due to so many reasons are there. Even if you apply good quantity or proper quantity of nitrogen to the soil, sometimes it may not be available to plant because of the water shortage during summer, because the water is the only element which conducts all the nutrients to the root system, and it is assimilated by the plant system also. Sometimes due to heavy rain, water stagnation may be there because of the seepage water, or because of the percolating or infiltrating water, the nitrogen will be leached down. So in that case also, this type of symptoms will be generated, even though if you are doing a properly applied nitrogen in the field. So some of the management practices also affect the nitrogen or nutrient uptake. So next one is the potassium. But in case of a phosphorus, we didn't find any peculiar symptoms of deficiency. So that's what phosphorus is required a very less quantity, but it is very essential. But now I am telling about this potassium deficiency symptom. You see, this potassium deficiency is potassium is highly mobile in all the plant system, and the deficient symptom is occurring in the lowermost leaf only. It is starts from the lowermost leaf. Even if you see this coloration of the leaf, affected leaf, that orange yellow coloration will be there. It is not pure yellow. It is orange yellow coloration is there. At the same time, if you see the withering leaf, the tip of the leaf, it is bending towards the tip is facing towards the base of the plant. It is looking like some parrot beak appearance type shape is there. You can see this type of symptom. So this is called potassium deficiency. Even if you can see this type of a symptom in this photograph also you can see. So this is the field view of potassium deficiency. So here you see this bold coloration, yellow, orange yellow coloration starts from the tip of the leaf. The tip is bending towards the base of the plant. So it starts from the tip of the leaf, from the lowermost leaf only. It is always start from the lowermost leaf. Mostly this type of symptoms occur in sandy type of soil, because when you apply potassium, due to sandy nature of the soil is not able to hold the potassium whatever you're applying to the soil in the root zone, and due to heavy flooding or due to heavy rainfall, what happens, the leaching loss will be there. Potassium may not be available to plant. This type of symptoms will be generated. Then if the potassium deficiency is there at the time of bunch development or floral initiation stage, what happens? This type of symptoms will be developed. Uneven ripening of the bunch. You see, this type of bunch, if you take it to the market and you are selling it, you will fetch less price only. You will not get high price for this bunch because of this single bunch which is ripened early when compared to other ants. So this is uneven ripening. This symptom is also is one of the symptoms because of this potassium deficiency. Maybe some other reasons also, but potassium deficiency is one of the reasons for this uneven ripening. So this is all the major problem in banana cultivation. If you get such type of uneven ripened bunches, you will not get good yield. Even you will not good price also in the market. So this is another problem. Then calcium deficiency. So when you talk about this nutrient proportions, nutrient antagonistic and synergistic effect, if you see this potassium and calcium is, they are always antagonistic. If more amount of potassium is there or activity of potassium in the soil is there, more it is there, then it definitely affect the calcium uptake or the activity of calcium is reduced. It is antagonistic. Opposite effect is there. So sometimes what happens, farmers are thinking if application of more potassium increases the yield, sometimes increase the quality of the fruits also. But more enthusiastic application of this potassium, what happens is indirectly induces the calcium deficiency because the calcium activity in the soil is reduced in the presence of higher amount of potassium. So this is another problem. You see, this calcium deficiency symptom only midrib is there and leaf lamina is small formed. It's like a zigzag sawtooth like appearance it is there. This is due to calcium deficiency. You can see the field view of this calcium deficiency. You can see this only midrib is there and leaf lamina is not properly formed. So this whip-tail like appearance is taking place. So this is due to calcium deficiency. Sometimes farmers they are not knowing the which is the disease which is the deficiency symptom. This is also calcium deficiency. This due to calcium deficiency, the midrib is there and lamina is not properly formed and leaf size is also reduced. On seeing this type of a symptom, a farmer definitely say it is suffering from bunchy top disease, a viral disease, like he is thinking that. But actually, this symptom is resembling the viral disease bunchy top, but it is not bunchy top disease. It is due to calcium deficiency. So in most of the cases, the farmers, they are not able to which one is a disease, which one is a deficient symptom, and they are not able to understand that. Simply they are going to fertilizer shop and they are telling the symptoms, and the fertilizer shop owner, he is telling something, you can remove all the plants like that, but actually the plant is suffering from calcium deficiency. Mere application of calcium fertilizer is sufficient for that, but most of the farmers, they are not knowing, and this is the problem here. So by this way, so everybody should be thorough with what is deficient symptom, which one is a disease we should do. Otherwise, the total loss will be incurred by the farmers. So here, maybe due to general symptoms appear in the early stages, early summer stages, or during the flush growth. In case of, say, for example, if the plant is growing in the stage of 5th, 6th month, it is a rapid growing stage only it is there. So what happens? The dry matter production will be very rapid during 5th and 6th month of the plant of a banana crop, you see. But if you take this during this rapid growth stage, to that extent, to the rapidity of that plant growth, the calcium is not mobile up to this expanding type of tissue. So what happens? There is some dilution effect is taking place because calcium is less mobile or partially mobile in plant system. So to that extent, to that rapidity of that extension of that leaf system or tissue system, that calcium is not able to accumulate in that growing part. So that's why the calcium deficiency is taking place. This is also another reason. So due to over application of potassium also, it is due to antagonistic effect, calcium uptake is reduced. On the other hand, sometimes what happens due to rapid growth, because of the dilution effect, calcium is not properly filled in the leaf system. So this type of symptom is occurring here. So there are so many reasons for calcium deficiencies, and we have to pinpoint what is the root cause of it, and we have to rectify it. Otherwise, we cannot rectify the calcium deficiency symptom. So next one is the magnesium, secondary nutrient, macronutrient magnesium. You can see this type of symptoms in the middle midrib region. It is a dark coloration is there. During in this peripheral region, you can see that dark green coloration is there. But in between region, you can see this pale yellow coloration is there, pale green coloration is there because of the lack of chlorophyll. Because magnesium is very essential for chlorophyll formation. That is the key element for chlorophyll. So that's what the magnesium deficiency definitely leads this type of symptom. So this type of symptom is occurring at middle range leaf only, not in the top leaf, not in the bottom leaf. In the middle range of leaves only it is occurring. So it is very peculiar symptom. You can see the field view. It is a middle range of leaf. That mid-rib region, it is a dark coloration is there, and the peripheral region is also dark green coloration is there. In between region, you can see this is yellow coloration is there. This is due to lack of chlorophyll. So this type of magnesium deficiency symptom also it is induced by the presence of more amount of potassium. By overemphasis, we are applying more potassium. Definitely, this type of magnesium deficiency symptoms also will be induced in banana plant. So we have to be very careful while handling these nutrients because potassium is antagonistic with calcium, potassium is antagonistic with magnesium. So mere application of all these nutrients is not sufficient. We have to see all these nutrients are existing in the balanced condition or not. That is very crucial point. You can see this next slide I will show. This is the blue banana symptom. This is also due to magnesium deficiency. If over application of potassium is taking place, this type of blue tinges is taking place. By this also yield will be reduced. Mostly this type of symptoms it is occurring in the variety called Nendran, which is used for chips purpose. In the Nendran variety, Nendran banana, you can see this type of symptom is called a blue banana with application of a high amount of potassium and it induces the magnesium deficiency. That's why that I mentioned that ratio between these nutrients. This potassium is antagonistic over calcium, potassium is antagonistic with magnesium. But calcium and magnesium is synergistic. So we have to see this ratio between these three nutrients. If one part of potassium is there in the soil, at least 10 parts of calcium should be there and 5 parts of magnesium should be there. So this is the optimum ratio we identified for banana cultivation. Mere application of all these nutrients is not enough. We have to see whether all these nutrients are in this proportion. Otherwise, it will not be useful for banana cultivation. One should be very thorough in it. So next one is the secondary nutrient, secondary macronutrient, sulfur. Sulfur deficiency, how it is. You see, this is the newly opened leaf. It is just now it is opened leaf, and this is the inner margin. So this is the outer margin. So in the inner margin, there is a lack of chlorophyll. You can see if you move this, I will move the cursor. It is moving from this side. That yellow tint is gradually it is decreasing and dark coloration is taking place. So that outermost region of the newly opened leaf will be looking like yellow coloration is there and gradual decrease in yellow coloration and increase in green coloration towards the inner leaf margin. So this is occurring in the topmost leaf only, you can see. So in a plant, if you say banana crop, the topmost leaf is very crucial, very essential for photosynthesis. When this, due to this type of symptom, if it is occurring in the topmost leaf, definitely yield will be reduced. Some by 30 to 35% yield reduction will be there. Definitely it will be there, some yield reduction. So we should be very careful. So where this type of symptom it is occurring. For example, in case of potassium, the lowermost leaf it is occurring. But in case of calcium, the deficiency symptom and leaf damage is occurring in the topmost leaf. In case of sulfur also, topmost leaf. In case of magnesium, middle range leaf. So according to the position where the symptoms occurring in the leaf system, that may show influence over the yield. So we have to be very careful. Whenever this symptom is occurring in the topmost leaf, one should be very careful. Otherwise, the yield reduction will be very drastic because in all the plant system in the field, it is happening the same level. The farmer is not able to identify the yield difference in one plant to other plant because in all the plant it is suffering. But if you see that average yield reduction will be 30 to 35% and it is invisible to farmer also. So we have to be very careful while managing this type of nutrients. Then comes to micronutrient. So why it is called micronutrients? Micronutrients are required by the plant system very less quantity, very meager quantity, but The absence of this micronutrient definitely affect the yield. So micronutrients are very essential, without which a plant cannot grow, and without which the macronutrient use efficiency also will be affected to a drastic level. So micronutrient is very essential. In case of iron deficiency, how it is working? You see, this iron deficiency, once again, the deficient plant will show the lack of chlorophyll, and once again, the symptoms is occurring in the topmost leaf only. Starts from the topmost leaf, all the micronutrient symptoms. So I already mentioned, if the topmost leaf is getting affected, means yield reduction will be definitely by 30 to 35%. So we have to be very careful. You see the field view of this iron deficiency. So iron deficient plant, you see the topmost leaf, it is getting affected because lack of chlorophyll. And fortunately, this type of field, we observed this type of some concur nodules, that calcium content is more in this type of soil because of the high pH. As per this, our soil test report, this soil is having very good amount of iron, but that due to presence of this concur nodules, the calcium carbonate in this, there is high content of calcium. What happens? The pH of the soil is increase up to 8.5 to 9. It is there. So because of the high pH, what happens? All the iron, whatever existing in the soil, is converted into ferric form, oxidized form, Fe3 plus form, which may not be available to plant. That's what this plant is suffering this type of symptom. So even though the soil is rich in iron, but the plant is not able to absorb all the iron because of the high pH in the soil. So that is another reason. pH is playing major role in the uptake of micronutrients from the soil. So that also we have to give emphasis on the reducing of the soil pH by applying some amendments to the soil. That also another part. So in management aspect, we have to see all these aspects only. Not only for the plant system, we have to see the soil system also. The pH of the soil, then alkalinity of the soil, sodicity of the soil, everything we have to see. So in case of iron deficiency, you see this topmost leaf will be affected, and definitely will the yield will be reduced by 30 to 35%. Because of the high temperature, sometimes what happens during the summer season only, this type of symptom will be visible. What happens during the summer, due to high temperature, what happens? Water is moving upward from the lower region to top region. After sometimes the water, it is where it is accumulated, will be getting evaporated from the soil, and the salt which came along with this movement of upward movement of water is retained on the root zone only. Only water is escaping as a vapor, but all the salts, whatever it is coming from the below ground level, is accumulated in the root zone. So what happens? The soil rhizosphere pH will be increased drastically in summer. So in that case, during this summer, this type of symptom is predominantly visible in all the regions. Wherever, even if you apply good quantity or sufficient quantity of micronutrients here, because of the soil pH increase, the uptake is reduced. So that management aspect you have to consider. That soil management aspect, we have to be very careful for optimum uptake of micronutrients. So this type of another copper deficiency, you can see this type of a forking-like appearance. So here is because of the copper deficiency, this topmost leaf, it is not opened properly because of this curved nature, because it is forking appearance. Because of the high temperature, what happens due to dehydration of the leaf, that is a very some falcid leaf structure is there, and it is not open. Furling of leaf is very difficult. After sometimes what happens, the newly emerging leaf will come out. So by tearing this roll. So what happens, all sorts of tearing, all sorts of damage, it is happening in the topmost leaf once again. You can see this type of a copper deficiency with the long shot view. If you see, it is like resembling like an umbrella type appearance is there. You see, all the leaves are drooping. It is not stiff. The topmost unfolded leaf, what happens, hooking is taking place, and it is not properly opened, and a newly emerging leaf is tearing it, and it is coming out. So all sorts of leaf damage is happening in the topmost leaf. So once the topmost leaf is getting affected, means that is actively photosynthetic leaf is affected, means definitely yield will be drastically reduced. So we have to be very careful in managing the micronutrient deficiency. We have to keep the plant, banana plant, with sufficient quantity of micronutrients. Otherwise, we will face this type of problem. So next one, this is the another view of a copper deficiency. You see this spooking of leaf, it is taking place because of this copper deficiency. Then next comes zinc deficiency. Here also the zinc deficiency, the backside of the topmost leaf, if you see, the purple coloration is there because of the formation of anthocyanin pigment. That leaf width also will be reduced. That leaf will be very narrowed down. The width of the leaf will be narrowed, and sometimes you can see this type of symptom also. Intervenal fluorosis. Only tertiary veins are remaining green, and in between region you see that yellow coloration is there. This is called comb-like structure. This type of symptom also, it is very dominant in case of zinc deficiency area. You see this type of symptom also will be visible. It is pink coloration. Mostly in Nendran variety, we have seen this type of symptoms. And these are all creating lot of problem in formation of good bunches. That quality of the bunches also will be reduced. So one should be very careful in managing the micronutrient. Then boron deficiency, see, that leaf flexibility is reduced. The leaf is becoming very brittle. You can see this crinkling type of structure in boron deficient plant. Mostly in Neipoon variety, we have observed this type of symptom. And this is called a laddering structure. That is a term called a laddering. The leaf is becoming very brittle. If you crush the leaf with the hand, it will give some papery sound. That much brittleness will be there. So this type of symptoms, this type of deficiency symptoms will definitely reduce the yield by 20 to 25%. So all these micronutrients are creating a lot of playing major role, and their deficiency will be a problem at all. So to avoid that, what we have done from our research aspect, by doing some 15 years of continuous series of field experimentation, we have come out with a fertilizer micronutrient mixture called Banana Shakti. So, for example, a farmer is going to a fertilizer shop, he wants some ferrous sulfate or zinc sulfate separately for according to their symptom visibility in his own field. It is not available. If one nutrient is there, another nutrient may not be available. But in case of micronutrient, it is always better to apply in a mixture only. On proper proportion only you have to take. Otherwise, you will not get the proper result. So to avoid that, what we have done, we have standardized that proportion of all the micronutrients, which is very suitable for banana cultivation, we have arrived at, and we have made it into a ready to spray, ready to use micronutrient mixture called Banana Shakti. So this is our one of the very good technology what we have developed from our institute, and it is very well accepted by the farming community. Everywhere it is used, and it is having very good response to banana cultivation. Yes, by using this, at least some 30 to 35% of yield increase is observed. So it is very good product, and it is moving very well in our institute. Then when it comes to this significance of micronutrient, with some practical experience, I want to just explain how the micronutrients are playing major role in the uptake of macronutrients. If see, say for example, just I am comparing this macronutrients like a big rock, which is existing in our footpath, which is hindering our mobility. So we just want to remove it away. Then if you have this type of very big rock, this all macronutrients, say you just consider it as a macronutrient. If you want to move it properly, you have to use some crowbar. One big rod should be there for moving that. So we have to keep one small stone at that pivotal point. Then only we'll get the good leverage to lift it with the help of this crowbar. Without this, this is the micronutrient. If it is considered as a macronutrient, it's a big rock. If you want to move it with a crowbar, you have to keep some small stone at the pivotal point. No, that is the micronutrient. It's playing major role. Without this small stone, we cannot move this macronutrient. Another thing, I have compared this length of the crowbar with the soil pH. If you choose a short crowbar, you have to give more pressure to lift it. So that is comparing with the soil pH. Let us say pH is 3. In case of if you take a long crowbar, excess length, more than 8.5 soil pH is there. If you apply more pressure, the crowbar will be bending down, but it will not lift the rock, even the presence of micronutrient. So it is also not helpful. So you have to choose the optimum crowbar with optimum length, like the soil pH should be 5 to 8. In that case only, the usage of a micronutrient will be properly there, and the usage of a macronutrient also will be proper. So, though the presence of both macro and micronutrient, but the soil pH is playing major role. So the soil pH should be in the optimum condition. Otherwise, the presence of a macro and micronutrient are not helpful. Only mere presence of a micronutrient in proper proportion is not mere helpful, but the suitability of soil pH we have to consider. So that 5 to 8 soil pH should be there. We have to properly balance the soil pH. Otherwise, we cannot manage the nutrients. So soil pH is playing major role in any crop cultivation. So then comes to how to do this soil testing, soil collecting, soil sampling. Everything you may be knowing, and you may be dealt with in our undergraduate classes also. So this is by doing this, like in our institute, what we are doing in the December 5th, what we are doing this World Soil Day and everything we are organizing, and we are issuing the soil health card also, and along with the recommendations to the farmer. But whether the farmer is adopting the recommendations what we are giving in the health card, that is the question, very big question mark. So in that case, what happens to the farmer, even though the farmers are getting with good recommendations from our side, and they are getting all the advices properly, they are just going to a fertilizer shop, and the fertilizer shop owner is telling so much of fertilizers are there available, and whatever you want you can purchase for your banana cultivation. There some problem is starting. So the farmer is a total bit of confusion whether which nutrient, which fertilizer has to be used for banana cultivation. So the farmers will be totally confused. So in that case, what we are suggesting, only this tick mark what we are given here, that urea, superphosphate, muriate of potash. These three fertilizers they are making a wonder in banana cultivation. That is straight fertilizer. That too, the government is providing to the farmers at a subsidized rate only. So if when the farmer is going for all complexes fertilizers like 17, 17, 17, all 19 or 20, 20, 0, 15 like that, he has to incur heavy expenditure for purchasing it because of the low subsidy given by the government. But if you choose straight fertilizers like urea, MOP or straight single superphosphate, it's always better for banana cultivation. We can do wonder with it. So another thing in nutrient management, we have to see this type of 4R nutrient stewardship. That is 4R. What is 4R? What is that? Right source of nutrient we are using or not. We have to check first. And that right time we are using or not, or right rate, or right proportion we are using or not, the right place we are applying or not. We have to see these 4 points. Right source, we have to choose right time, right rate, right place. These are the 4 R's. Nutrient management or fertilizer management we have to see. So this is the general fertilizer recommendation for banana cultivation. These are all the names of the fertilizers I have given in English here. And this is the time of application. That is 3rd month after planting, 5th month after planting, 7th month after planting. So these are all the fertilizers what you have to use in banana cultivation. These are all the quantities of fertilizers to be applied per plant. In gram per plant I have given here. So the 3 components it is there. Right fertilizers, right source we are using or not. There is first R. That right proportion we are using or not. Right rate we are doing. This portion it is there. And right time whether we are applying the fertilizer to the plant or not. So these 3 R's it is covered in this fertilizer schedule. So one should be very careful in doing fertilizer management or nutrient management in banana cultivation. These 3 aspects we have to consider. Next consists the right place whether we are putting the fertilizer or not. That is the thing we have given this pictorial explanation here. You see this 3rd month if you are applying fertilizer, the fertilizer should be applied 1 foot away from the plant. If you are applying fertilizer for the 5th month stage, 1.5 feet away from the plant. In case of 7th month after planting, you are applying fertilizer 2 feet away from the plant, because banana is a long duration crop. All total dosage of fertilizer, we cannot give it at one-time application. We have to split it into 3 stages, at 3 critical stages, like we have to take 3rd month, 5th month, 7th month. But every time with that plant stage, the plant growth stage, that distance of the plant fertilizer application should be increased properly. So 4R it is covered. First one is right fertilizer, right proportion, right time, and right place. So 4R's we have covered here. This is the method of application of fertilizers. And apart from that, during that blanket recommendation, so many agriculture universities, state agriculture universities, or even agriculture departments of different states, they have given at a different blanket recommendations for banana cultivation for NPK rates. But what we have developed, this is soil test based nutrient management. That is the crucial thing we have followed here actually. So here, based on the soil test, if your initial soil is having this much of nutrients and you want to get this much of yield target, so how much nutrient has to be applied? So this type of fertilizer adjustment equations, the fertilizer calculators also we have developed. Some ready reckoners also we have developed. So based on the soil test based nutrient management, we can do wonder with existing source of nutrients, with incurring optimum expenditure, not a high expenditure. So this type of, as a summary, I have given this total pictures of all the macronutrient deficiencies is a summary nature, and you can see. And this is the micronutrient I already mentioned, the micronutrient mixture Banana Shakti, what we have developed in our institute. After this is the solid material. Now we have come out with a liquid formulation of Banana Shakti also. So for 1 acre of Banana Shakti, we have to give as a foliar spray. We can use 5 liters of such bottles we can take, and for 1 acre we can give. So this in case of micronutrient, we always recommend the foliar spray. I already mentioned why, because of the high pH soil. If the soil pH is more than 8.5, when we apply this high pH soil with all sorts of micronutrients to the soil, all the micronutrients will be fixed in the soil itself, may not be available to plant. To avoid that, what we are recommending, always you can go for micronutrient as a foliar spray only. So don't go for soil application, whether it is the soil pH is more than 8.5 or not. You can don't bother about it. You just go for foliar spray only. Then only the use efficiency of all the micronutrients will be very high. So that's what we have come out with, all the macronutrient mixture in the solid form and even liquid form also we have come out. And these are all the farmers what they are getting benefit out of it in Tamil Nadu. This some 26 kg in Karur district of Tamil Nadu, that Naipon variety. In Kadalur, they have got some 24, 25 kg of Naipon banana. So with application of all micronutrient and the proper management of micronutrient, the use efficiency of macronutrients also will be improved by the proper management of micronutrients. So that's why the farmer is able to get all sorts of good yield and good bunches. All the farmers are very happy with this product. And now we are trying to bring out some nano formulation of this Banana Shakti micronutrient mixer. So this is all our working program, and we have a collaboration with conventional university, Shastra University is there in nearby our institute, and with them we are doing some collaborative research work, developing nano formulation of this Banana Shakti. Using this type of nano suspension, we have bring out with Banana Shakti, and we are the experiments are on, and we are using as a drone spray nowadays, because using drones at high concentration, that is low volume spray. It is having some 10 liters capacity tank only, and we can give high concentration of a spray solution there itself, and we can spray over 1 acre of land with one flying itself. So that method of application also just we have changed for micronutrient. So we using this type of drones, the topmost leaf it is covered. If you are applying from the ground level using some backpack spray or something, foliar spray, you can cover only lowermost leaf only, the lower side of the leaf only, if the plant height is more than the spray band. So in that case, if you use this type of drones, what happens, the topmost 5 leaves, it is covered with the application of all micronutrient as the Banana Shakti spray or micronutrient spray. So the use efficiency is very high. So we are recommending this type of technology also. Some advanced technologies we have to switch over in case of micronutrient management for banana cultivation. Then comes the nutrient recycling. That is another part. So because when if you see this soil banana plant growth system, there are so many pools are there. Some organic content, some if you here the nutrients are applied. There is the plant stalk, leaves, calm, the root system. It is there. During the bunch harvest, some portion of the fruit is removed, and the rest of the thing is remaining there itself, which is having very high amount of nutrients what you have used for this plant growth. And once again, it can be recycled there itself for the next season also. So there are, if you take the dynamics of the system, the nutrient recycling is very important in case of banana cultivation. You can see this type of at a time, this type of NPK, calcium, magnesium, the kg per hectare is existing in this such categories of a plant system and soil system. So this is the ratio proportion kg per hectare are given here. And we have done some good dynamic nutrient dynamic studies also. So in that case, we have come out with this type of observation also. So how much dry matter production is there in different segments? In leaf, it is 13%, petiole 3%, 24% for pseudostem, 16% go for corms, root 2%. And in case of bunch, some 8% peduncle region, 33% of dry matter is from the root, and 1% is from the male, but totally 100% is there. It is segregated into this type of categories of segments. So for dry matter production, in the dry matter production, how much nutrient is existing? You see. So in case of nitrogen, if you see, we have one for 1 hectare, some 128 kg of nitrogen is existing in the leaf itself, but only removed through bunch. How much it is there? You see, some 444 kg of nitrogen it is required for 1 hectare of banana. In that, due to bunch harvest, only 112 kg of nitrogen is removed, and the rest of the thing it is remaining in the residual part. So that has to be recycled properly for the next season. If you cut all this waste material and it is thrown out of the field, it is waste only. So the nutrient recycling part is also very essential, very important in nutrient management. So this type of nutrient dynamic studies also we are doing. You see, this type of this much of nitrogen can be saved in the next season if you do proper recycling. In case of phosphorus, if you see, some 69 kg of phosphorus it is taken up totally, and removal is 24% through bunch, and 45% is remaining in this waste. This can be recycled properly. Then in case of potassium, you may wonder that nearly more than 50% of potassium is removed through bunch. You see, some 932 kg of potassium, it is totally taken up by the plant in 1 hectare. And through bunch harvest, 485 kg of potassium is removed, and residue is 447 kg. It is available for recycling. So this large quantity of nutrients existing in the root system or the plant residues or farm waste, it has to be properly recycled in proper nutrient management. So then only the soil system also will be optimum for soil microbial aspects, and physical chemical properties also will be improved in the soil system. So before recycling, it has to be properly composted. As such, a fresh material, waste material cannot be applied to the soil system. It has to be properly composted using some technologies like vermicomposting or microbial composting also. If you take before composting, if a pseudo stem, that stem part, that waste material, it is having the CN ratio of 60:1. Here the nutrients are not available to plant system, but once it is chopped into small pieces and it is fed with earthworm, once you properly collect this vermicompost, the CN ratio it is reduced to 9:1. So this nutrients existing in this compost is highly available to plant system. Here the nutrient is not available to plant, but here nutrient existing in this compost, it is highly available to plant system. So by that way also the nutrient releasing pattern also can be modified in case of with the help of some composting technology. So for nutrient recycling, proper composting is the important one. So like this, how much nutrient we are recovering, this type of studies also we have done. And nutrient, it is called DRIS system, diagnosis recommendation integrated system. How it is working? You can see this type of studies. This one reputed scientist, Liebig, he proposed this theory called law of minimum. So you may be having all sorts of nutrients. Let us say it is just a comparison. Here it is a water tub made up of wooden tub made up of different wooden strips of different heights. Each stripe is representing each essential elements like zinc, magnesium, copper, manganese, K2O, nitrogen, P2O5, calcium, like this. So in this example, he has taken this P2O5 strip is very short when compared to other stripes. So if this is the condition, if you pour water, you can store the water up to this level only in this tub. Beyond this, even if you pour more water, it will be wasted like this. So in this case, the P2O5 strip is very crucial and it is the limiting factor. So because of this limiting nature, the yield is restricted up to this, though the presence of all the other nutrients in excess quantity, the presence of this particular nutrient on the lowest level, the yield is this much only. You cannot increase the yield. So here comes the balanced nutrition. So what happens if a farmer fails to identify this is the limiting element, he can increase the height of this strip up to this. Next level is the calcium and nitrogen. This is the limiting element. So by this way, by iterating processes, some of the things we can adjust all the level properly so that we can retain highest amount of water in this tub by adjusting all the nutrients. That is the fertilizer management. He is just comparing this type of situation with the nutrient management. And this is the DRIS concept what we have developed, because we are taking in this concept single nutrient we are not taking. The proportion between two particular nutrients we are taking for this DRIS indices development. Say for example, nitrogen versus phosphorus, potassium versus phosphorus, nitrogen versus potassium, like this. So like this, for this example, this is the center portion, like NPK ratios of all this combination. 6.13, 6.80, 7.67. This is the optimal level. So if the plant system is having this type of combination, the yield will be very optimum. If once this nitrogen level is increasing, the proportion of potassium will be decreasing. In this case, the nitrogen is increasing, phosphorus is decreasing. So there may be imbalances will be there. So once if your plotting is occurring in this region, some out of balance nutrient management is there. So if you have to maintain properly, means according to this indices for banana cultivation. So these points should be maintained at this level so that we can get proper yield. So this is the type of indices work. It is more scientific in nature. We can explain with the help of some Excel packages also there. If time permits, I will show. So this is the Excel package we have developed for this DRIS indices. This is not due to the soil parameters, which is only nutrient content in the leaf tissue parameters only we have taken here. So this is a major advantage here. And already mentioned this fertilizer adjustment equations. So this also we have converted into Excel, user-friendly Excel package with the help of some computer knowledge person here. And like that, some ready reckoner also we have developed for the fertilizer adjustment equation. If time, I will show that the demonstration of this package, how it is working. I will show. This is our fertilizer adjustment equation. Is it visible, sir? Hello.
Sir, hello, sir.
Is it visible?
No, sir. Thank you slide is there, sir. Thank you slide is visible.
Okay, okay. I have just shown this Excel package also.
Oh, Excel package.
Whether it is visible?
No, sir. No.
Just a minute. I will come. Now it is visible?
No, sir. No, sir. You do one thing, sir. You paste that in one another slide, sir. Immediate slide before. Then it is possible to visible, sir.
Just okay. That Excel package, if time permits, I will share with the WhatsApp group also.
Okay, sir.
That you can share with our audience. Unfortunately, it is not visible here.
Okay, sir. Thank you, sir.
Okay, if any doubt is there,
Any questions?
clarify.
We will see, sir. Right. Any questions? Any questions are there? Please post in your chat box.
Hello, any questions are there, friends?
Sir, I also checking chat box where no one is posted, sir.
No one has posted. Okay, if any doubt is there, you can anytime we can contact through the organizers. We can give our phone number also. If any doubt is there, you can clarify then.
Thank you, sir.
Okay, welcome.
So, on behalf of organizing committee, College of Horticulture, Venkatramanagudem, it is my privilege to extend my heartfelt thanks to Dr. K.J.Jayabaskaran, sir. Sir, we explained elaboratively regarding nutritional management and physiological disorders in banana. Sir, very information has given in this lecture that is very useful to our students. Thank you, sir. Thank you very much for participating in this program and spending your valuable time with us. And I also thank all the students, teaching staff, and the research staff from the different stations for participating in this program. Thank you very much, sir.
Thank you.
Thank you, one and all.
Thank you.